Lab 4 on case study on routing configuration. So in this lab, we will learn how to use static route, default route, and dynamic routing protocol. Lab 4, case study on routing configuration. So in this lab, we'll try to combine the use of static route, default route, and dynamic routing protocol in a network scenario. We also will revise your sub-networking in IP allocation. This is a scenario where you are a network engineer. You are asked to plan and implement a network based on user requirement. So you need to design the network diagram, divide the available IP address space, and this should be done in a manner to allow efficient utilization of the address space with minimal waste of IP address. So you need to do your subnetting here. Okay, so let's look at the network. Okay, so this is a network. We have 1, 2, 3 local area network. We have 3 routers connected together. And we have a ISP router here that's connected to R3, and this is the internet. So we have 4 routers, 4 PCs, and 1 switch. Okay, this is a requirement. So you're supposed to subnet 192.168.6.0/24 network. Okay, and this is the user requirements for the 3 groups of users. Group 1, 100 IP address. Group 2, 25. Group 3, 58. Okay, so based on the user requirement, you're supposed to do your subnetting. Okay, so the subnetting already done for you already. Group 1 need 100 IP address, so we'll use a .128. This will give us 128 minus 2, minus the network address and the broadcast address. This gives us 126 IP address, which is sufficient for 100 IP address. Okay, next we'll do group 3. Okay, group 3 requires 50 IP address, followed by group 2, 25 IP address. Okay, which is why we do group 3 first, because we need to do the one with the most number of hosts, followed by the next one, followed by the next one. Okay, so this will be done in descending order. So group 3, 50 hosts. So subnet mask we can use is .192. This will give us 64 IP address minus 2, 62 IP address. And this will be the address range. And lastly, we'll do for group 2. Group 2 requires 25 IP address. A .224 subnet mask will give us 30 IP address. So good enough for group 2 user LAN. Okay, then we also need IP address for our serial link. Serial link between R1 and R2, R2 and R3. So this will be the subnetting solution for our network. Next, we shall assign the IP address to the PCs. Okay, so PC1 is in the group 1 network. Okay, so we give an IP address inside group 1 to PC1. And of course, PC1, the default gateway will be R1G00 interface. Okay, PC2 is in group 2, so we give an IP address inside group 2, and the default gateway will be R2G00. So an IP address in group 2. This is the default gateway, which R2G00 interface. Okay, PC3 is a bit interesting because PC3 network is connected to 2 routers, R1 and R3. We can either use this as a default gateway or this as a default gateway. So both of them can be used as a default gateway. So you can choose either this interface R1G01 or this interface R3G00. Okay. So we can use either one of them as a default gateway. So we will also use one of the IP address inside user 3. The PC4 IP address is given over here. Okay, so you can use and configure PC4. Okay, so we have done our subnetting, we have assigned our IP addresses, we are all ready to configure our network. So go ahead, proceed to Polymorph. Okay, so inside Polymorph, go to Learning Resource, Practical, Lab 4. Okay, download the packet tracer file. So, and open it. When you open it, you should see this network, okay, which is our network over here, all the device in our network. Okay, so we're supposed to do some pre-configuration, erase the switch VLAN, erase the start. Okay, this one you can actually skip because the switch is already clean, so you don't have to do this. Okay, configure the PC with the IP address, mask, and the gateway. And also for the router, configure the host name, IP address, copy for the DC interface. So I think now you can pause the video and start to configure all this. Okay, I think you should not have any problem configure them. Okay, so in case you have any problem, you can always look for me in the next lesson. Okay, remember, configure them using the command prompt. Do not use the config tab in Packet Tracer. In the lab test, you are not allowed to use the config tab. You must use the command line interface. Okay, so go ahead, pause the video, and then configure the IP address for the PCs, the subnet mask, the gateway for the PCs, and also for the routers. Okay, I hope you have finished configuring. Okay, so for me, I have already configured them. I have connected the routers, the PCs, configured the IP address, so the device all ready. So now we need to enable routings on the routers. Okay, let's go back to the lab sheet. Okay, so this is a configuration for R1. Okay, we need to turn on router read using version 2, and we need to enter the network command for the 3 networks that's connected to router 1. So what are the 3 networks? Okay, router 1 is over here, is connected to group 1 network, is connected to the serial link network over here, is also connected to the Ethernet network over here. So there are 3 networks here. Okay, so we will enter the network address of these 3 networks. Okay, so let's try to do it now. Okay, I'm going to turn on router 1. Okay, router read. Okay, I'm going to run version 2 now. Okay, with version 2, okay, I'm supposed to run the network command. Okay, so the first network is the 192.168.6.0. I'm going to copy this and paste. Okay, so this is for the first network, which is the group 1 network over here. Okay, so advertise the first network. Let's advertise the second network. The second network, okay, let's say it's for this network over here. This is the group 3 network. Okay, this is the group 3 network. Okay, group 3 network will be the 6.128. Okay, so network 6.128. Oops. Okay, the last network will be our serial link network, which is the .66.6.224 network. Okay, this is the next network. Okay, so now the 3 directly connected network, I key in the network command for router read. Okay, if you remember in lab 3, we discussed this. Okay, RIP is it was started off as a class-through routing protocol. So the command here, the network command here, they actually only accept the class-through network. Okay, so 192 is a class C network. So for class C network, only the 3 numbers, the first 3 numbers is the network bits. So if you remember, the last number, whatever you type, will not be accepted by router read. They will just put in 0 over here. Okay, let's just look at the running config. Okay, look, show run, see? Although I key in 192.168.6.128 and 6.224, it was never reflected in router read. Okay, whatever you type in the last number, they will just replace it with 0. So actually you only need to type in 16.0. Okay, but okay, this happened that because all 3 networks are the .6 network. So if you happen to have one network that is not in the same class C or in the same class of the network, you have to type in the network command. So we put in 3 network command for you, just in case you forgot. Okay. This is just to play safe. Enter all the 3 networks. But effectively, you only need to enter one of them. So this will be the command to type in for R1. Okay. And for R2, let's look at R2. Okay. R2 is also connected to 3 networks. And it happens that all these 3 networks is also the 192.168 network. So effectively for R2, we also need to type in the same commands. So I'm just going to paste the command over here. So it's same router read version 2, and again we only need to type in the 6.0. Because all these 3 networks are the 192.168.6.0 network. So only just one of them. Same thing for R3. For R3, this is a 192.168.6 network. This is also 192.168.6 network. How about this? This is a connection to the ISP. Let's ignore this for the time being. So for R3, I'm going to do the same thing. So same thing, router read version 2, 192.168.6.0. So by entering this, let's look at the routing table for R1 now. If you look at the routing table for R1, we have the RIP route for the 192 network. We also have the RIP route for the 228 network. Same thing for R2. So R2 also has the RIP route 1 for the 6.0 network, which is the user 1 network. This is the user 3 network. So user 1 and user 3 network. And for R3 should see the user 2 network and the user 1 group 1 network. Let's go to R3. Show IP route. So this will be the user 1. This is the user 3 network. You also have the .224 network. The .224 network will be the network between R1 and R2. The serial link port. So this will be the third remote network that R3 see. So with that, all the 3 PCs should be able to ping each other. Let's try. PC1 ping to 192.168.1. Let's look at the IP address of PC2. PC2 IP address is 6.200. So the reply come back. Let's try. PC1 ping PC3. PC3 is 6.150. Let's try to ping 6.150. So the reply come back. So finally let's try to ping from PC2 to PC3. Same thing, ping 192.168.6.150. So PC2 is able to ping PC3. So all the PCs are now ping each other. We are left with one more network, which is the internet. So for the internet, we will use default route and static route to configure for the internet. So we will do that in the next video.